First of all, good afternoon, good morning. Welcome to this colloquium from the organizers, Monica Pepe Altarelli, particle physicist, and myself, Tullio Basaglia, head of the library. Before I introduce the speaker and the topic, please let me set up a few house rules. Our speaker asked us to organize this colloquium in form of an interview. Therefore, we already prepared a set of questions. Of course, you're also welcome to submit questions. You are all muted, and I would like to ask you to submit your questions exclusively in the chat for practical reasons. Today's speaker is Professor Daniel Kahneman, Emeritus of Psychology and Public Affairs at Princeton University. For his work on psychology of judgment and decision-making, as well as behavioral economics, he was awarded the Nobel Prize in Economic Sciences together with Vernon Smith in 2002. Professor Kahneman, you already participated in the CERN Sparks event in September last year. Thanks a lot for being again with us. The topic of today is noise, variability in judgments that should be identical, which is also the title of your latest book, written together with Olivier Sibony and Sunstein. Now I'm going to give the floor to Monica for the first question. Please, Monica.
Okay, so thanks again, Professor Kahneman, for being with us today. So you wrote a book which is titled Noise, a Flaw in Human Judgement. Can you please tell us why you decided to write such a book?
Well, we tend to think, a very good way to think theoretically about judgment is to consider judgment a species or a kind of measurement, where the measuring instrument is the human mind. And that then you can bring the theory of error to bear on judgment. And the theory of error distinguishes two types of error. So when you're measuring the length of a line or any physical characteristic that this is your field measurement, there is, we assume, a true value, and therefore each and every measurement has some error in it. The average error is the bias, and the standard deviation of the errors is noise. And the classic formulation, which is used in most sciences, so far as I know, is, well, it's Carl Friedrich Gauss's theory, by which, where he measures the impact of errors by the square of the error, not the absolute value, but by the square. And the overall inaccuracy is measured by the mean squared error, the average of the squared errors. And that is exactly equal to the square of the bias and to the square of the noise. That is, it's the average, the square of the average error, and the square, the variance of the error, the square of the standard deviation. Now, the reason that this is sort of important to our story is that the psychological study of judgment has been almost entirely focused on bias. And to some extent, maybe I've had something to do with it, because we, together with my colleague Amos Tversky, we started a study of bias a little more than 50 years ago, which has become quite common and quite influential in social and in cognitive psychology. But what I remarked, a while ago, was that noise and bias in the mean squared error formulation are really equivalent. They have the same weight. And yet we seem to pay attention only to one of these kinds of errors and not to the other. So that's the basic concept. I will add, just to bring it alive a bit, in terms of what was the motivation for the book. A number of years ago, about 7 years ago, I was involved in consulting with an insurance company, and I had the idea of carrying out what today we would call a noise audit. That is, we constructed a set of problems which were quite representative of the problems that the employees of the company performed every day. So underwriters assess risk, put a dollar value on the risk. So we presented quite realistic problem that the organization constructed to a large number, about 50 underwriters. And and each of them put a dollar value on each of several risks. Now I want to mention a question that we asked the executives, but I can ask you the same question, and I'm quite sure that you'll give the same answer internally as the executives. If you take two underwriters at random, and this is a well-run company, if you take two underwriters at random, by how much do you expect them to differ in percentage of the average? That is, you take the sum, you divide by 2, you take the difference between them. Now you divide the difference by the average. And the standard answer, the mode of the distribution, the most frequent answer is 10%. And I'm pretty sure that 10% is the number that occurred to you as you listen to me, because we have studied that now in a number of places with more than 1,000 respondents of various kinds, and 10% is the mode. This looks like a tolerable difference. It would be a tolerable difference in your world, but when you're talking of judgments, a 10% difference on a quantitative judgment looks more or less tolerable. So and now it turned out in that study that the difference, the average, the difference between two randomly chosen underwriters was about 50%, 50. That is 5 times as much as people had expected. And it turned out also that the organization had no idea that it had a noise problem. And the decision to write the book, it took a while to reach that decision, but that was really the beginning of the book, that there seems to be a lot of noise. We had the statement that wherever there is judgment, there is noise, and there is more of it than you think. There's a lot of noise. Noise is ignored. So we decided to see how much noise there is in various contexts, to develop a sort of theory of noise, to try to understand it. And that's what the book is. It is a premature effort, I would like to add. In general, when one has an idea of that kind, it should take 20 years to get to a book. You should study it, you should research it, you should give a lot of talks and get a lot of feedback. But I was 80 when I began the process, and I didn't think that I had 20 years. So we hurried the process and got the book out about 6 years after I finished.
In the book, you give another example. You talk about the situation of defendants in facing justice in court. And you write, in our world, they face that in reality, in theory, they should face justice, but in practice, they face a noisy system, or even a lottery, you call it. So can you please describe the striking results of the study on noise in judicial decisions in the US?
Yes.
Which is similar to what you just told us about insurance companies.
There's been a major debate on noise in the judicial system. It was noted about 40, 50 years ago that this actually, some people treated it as a scandal and that you had to intervene. And at that time, several studies were run in which basically noise audits, in which judges were presented with descriptions, schematic descriptions of defendants and their crimes, and they were asked to set a sentence, which could be a prison sentence or less than just a fine. And the amount of noise was shockingly large. It was actually proportionately about as large as the noise among underwriters. And I'll give you just an example. For the overall average sentence there were 208 judges and 16, and each of them made 16 judgments. The overall average of the sentences was 7 years. And for a sentence of 7 years, the average difference between two judges was just short of 4 years. That's a lottery. That's the lottery that the defendant faces, because the judge is selected in effect a process that, from the point of view of the defendant, is a lottery, and it determines the defendant's fate to a shocking extent. And I'll add just one more sentence on that, which is that judges refuse to admit that this is the case. They refuse to see the problem. And they feel that justice is what the judgment that comes to their mind. Yes.
Yeah, well, you write in the book that guidelines were established as a result of this study in the US to address the problem. But many people did not like them because they feel that they limit their judicial discretion. Can you comment on the attitude of the people with respect to prescribed guidelines?
It is difficult to believe. I mean, the noise problem just is one that people within the judicial system find very difficult to admit, because in principle, and this is very much like underwriting, you have a system. It's a system of justice or a system of underwriting in an insurance company, and you expect the system to speak in one voice. It should not matter which individual judge passes a sentence, and yet it seems to matter hugely. And so the answer that judges seem to be giving is that it's the unique interaction between the judge and the defendant, which cannot be captured in a vignette or in a description. And where that comes from, it's unique. There's one judge, there's one judgment, and that's how justice is made. A few months ago, I was invited to give a talk to 400 California judges. And somebody introduced the talk and introduced my work, and they introduced the concept of noise. And the example they used was medicine, was the fact that doctors don't agree on a diagnosis. The topic mentioning noise in the judicial system was so sensitive that actually it never came up.
Okay. So always along these lines, in the book you write that several organizations operate under the illusions of agreement. So can you clarify this concept?
Well, this was most obvious in the case of the underwriters, the insurance company. For the insurance company, as soon as it was mentioned to them, the extent of noise, they realized immediately that this is a big problem, because clearly
even financially,
the accuracy
financial
of the
implications, yeah.
It's a costly problem. So and yet they had not seen that the problem existed. And people within that organization, underwriters, were really completely unworried by the possibility that other underwriters would have reached a different judgment on the same problem.
Okay, but on the other hand, diversity of opinions is essential if you want to make progress. So what distinguishes this diversity from noise?
The diversity, can you hear a terrible noise here? It's okay.
Some noise, but now it's gone, yeah.
Okay, there's a big problem in my apartment, a big leak, and so they're trying to fix it at the moment. So now remind me in all of this what the question was, because I forgot.
I think we were talking about diversity and
Yes.
noise. So what is the,
So our definition of noise is that noise is unwanted, undesirable variability. So by definition, noise is a bad thing. And we only deal with noise where the normative expectation is that people should agree. And then variability is called noise. In many situations, disagreement is welcome and indeed absolutely essential. And so, for example, in forming an opinion, if you have a team that is developing an opinion about a problem, it's very good for the team to be diverse, and it's very good for the team to start with possibly different opinions depending on their individual expertise. But what you would expect is that at the end of the process, they would speak in one voice if they're speaking for a system. So we don't want film critics to agree with each other, but I think we do want judges to agree with each other, and those are the differences. We don't want people who are engaged in planning or devising or in engineering something to be in agreement with each other. We want them to be diverse, but there are also judgments where you expect uniformity.
Now, there is a question in the chat on noise. To what extent can noise in decision-making be reduced by coarse graining over judgments? That is to say, not one judge, but a jury. And this is what you were just mentioning.
I think I'm very glad of this question, because here there is a very big difference between bias and noise. And as all of you know, if you want to reduce noise in measurement, you take multiple measurements and you average. And this is a mechanical result. That is, the standard deviation will diminish with the square root of the number of observations. Yeah, so noise is something that in principle, you can guarantee that it will be reduced by aggregation of independent observations. Yeah. And the same is true for judgments, of course. The notion of independence is particularly tricky and essential. So if you have a process where people begin a discussion and form their opinions in the context of a discussion, like in a jury, you do not really have 12 independent opinions. You would have 12 independent opinions if people voted secretly early on, before the information or at any other stage, and did not share what they currently are thinking.
Yeah. Speaking of group decisions, you write that everything seems to depend on early popularity, and that so-called informational cascades can lead groups of people in truly terrible directions. Can you please explain this? What happens and how can we avoid this?
Well, there is a certain dynamic to meetings, which is really a violation of this principle of independence of opinions, which is that the people who speak first in meetings tend to have disproportionate influence on the final conclusion. And other people tend to conform and are drawn to conform to the people who speak first. Now, the people who speak first are the most confident usually, and they can be the loudest, but they're not necessarily the most accurate. And indeed, the correlation in general, the correlation between subjective confidence and accuracy in judgment is quite low. People have high confidence in judgment that are quite erroneous. And because that correlation is low, and because independence is violated, that is, that people are affected in their judgment by the judgment of other people, then there is a dynamic that can lead groups to make serious mistakes.
Another type of dynamics group dynamics that you describe in the group is group polarization that emerges from internal discussions in which greater unity, greater confidence, and greater extremism emerge, and frequently also in the form of increased enthusiasm. So can you explain what happens in such cases, or is it good or is it bad?
Well, we observed it first in the context of experimental juries. So we had a setup where we had, that's Cass Sunstein and I did that research more than 20 years ago, where we had large numbers of experimental juries. We had each person's opinion of the case before they started debating it. Then they debated it, and then people express their opinion again. And we observed a phenomenon of polarization, that groups were much more severe than their median member. And the reason, actually, you can feel this, is that there is an asymmetry in that the people who want to punish are more confident in their opinion, and they're likely to have more impact than the people who are reluctant to punish. And as a result, you have a systematic drift. In strategic affairs, you have discussions between hawks and doves, and the hawks have what I've called the rhetorical advantage. And so when there is a debate that includes hawks and doves, the drift is going to be in the hawkish direction usually.
Still on this, so George Lafferty asks a question from the chat. So many of the people in the audience will have experience of grading students. Could you comment on noise in student assessments and possible effect on life outcomes for the students?
Well, it's important in this context, I think, to distinguish chance from noise. That is, when a student comes into a group, then there is a lot of chance involved in the kind of mentor that they find, a better one or a worse one, in the kind of relationship that develop, in whether they're lonely or not lonely, alone. There are so many chance factors that determine success and that are really quite important in determining success. Noise is variability in people's opinion of a particular case or a particular person. And we know there is a fair amount of noise in assessing students. It's hard to detect because there is so much agreement. In general, among different people looking at the same students, they tend to agree. But in fact, that can be a matter of luck, because that is a case of people interacting and producing agreement through their interaction. We know that evaluations of scientific work, for example, the refereeing in journals, there have been many studies. This is a very noisy business. And so evaluating science is not simple, and it's a noisy process.
And there is a follow-up question. So we are many here today. I don't know if you've noticed, we are 562. So Igor asks, if I ask everybody how many miles do they think I have to drive from my house to my university, I can average all 560 answers, and the result will be no more accurate than if I ask just you. How serious do you think this problem is in real life?
That is really quite interesting, because the statement is incorrect. And the statement is incorrect in the following way. That is, if you ask 200 people an answer to a question that they don't know the answer, the bias is not affected by the number of observations. So the bias stays the same, but noise is mechanically reduced by aggregation. So if you measure accuracy by bias squared plus noise squared, then even in a nonsensical question, aggregating answers is going to reduce noise and mechanically improve accuracy.
Okay, let us move to values, intuition, and cognitive biases. So how can we keep our values and our facts separate? Does total objectivity exist?
Well, you're asking a psychologist, so you probably can guess the answer. I think objectivity, really doesn't exist, especially in things that matter. And here there is a really big difference. on things that don't matter, you know, I can accept somebody's judgment. Will it rain tomorrow? Won't it rain tomorrow? Well, I can change my mind. I can change my mind on many things that do not matter. But what is very striking is that people do not change their mind on things that matter. And this is true, not only about politics and religion, but it seems to be true in many cases in scientific controversy. So when there is a controversy, you have scientists. Now, in my discipline, of course, there is more disagreement, I assume, than there is in physics. But there is when people become invested in their opinions, they will not change their mind easily. And the distinction, it's not so much values and facts, it's what I want, it's my motivations, it's my emotions. It's separating emotions from fact. And that turns out people are not very good at that.
In decision making, people tend to give a lot of weight to their intuitions. And they're often proud of their intuition. What is your opinion about that?
Well, you know, it's obvious when you think about it that intuition is both marvelous and deeply flawed. So you can find examples of both. So the famous examples of intuitive expertise are in chess playing. So you have a chess master can just look at a complicated position and say, you know, white mates in 3 or something. And that develops in a particular way. You have physicians who develop that kind of intuition. Turns out that firefighters develop an intuition about what will happen next in a fire and how to deal with it. So there is such a thing as expert intuition. But on the other hand, there are many, many cases where people have intuitions that are worthless, and they hold these intuitions with the same confidence as if they had expertise. A number of years ago, I joined forces in what I call an adversarial collaboration with a colleague who became a close friend through this, who disagrees with me on everything. And in particular, he believes that in expert intuition, and I am on record as being a skeptic about intuition, and we got together to decide to try to find the boundaries, since we both agreed that there must be a boundary. When can we trust intuition? And to our surprise, after 6 years of hard work and many discussions, I think we reached a solution. And those are the elements. For an intuition to be valid, you want a regularity in the world. So the world has to be regular. So you can develop an intuition when you talk with your spouse over the telephone. You will detect your spouse's mood from one word. And that's because you've had a lot of experience and it's highly regular.
Is it so regular? Yes, maybe yes.
It's regular enough so you can pick it up, because people can develop intuitions even when there is some slight variability. So that's one condition. So for example, people who tell you that they have intuitions about the stock market are deluding themselves. They may have what feels to them like intuitions, but those are really not worth anything. They come with high confidence, but with no accuracy. The second condition is that you have to have experience. So for a chess player to become a chess master, they need both talent and years of experience. Similarly for a physician or for a firefighter. And the third condition is that not only does the world have to be regular, but the feedback that you get once you make a judgment has to be fairly rapid. If the feedback is delayed, you cannot learn from it. You cannot develop intuitions. So those are the three conditions under which you can trust your intuition.
What do you mean the feedback?
The
feedback is delayed. What do you mean by that?
What I mean, for example, is that if you make predictions about the success of students, of how brilliant they're going to be or how good they're going to be in 5 years, the feedback will be 5 years from now. You cannot develop intuition when you get delayed feedback.
Okay, because too many things can happen in between. Yeah.
And we just don't learn under those conditions.
Yeah.
Now, what is really important is that the subjective confidence that you have in your intuition does not qualify as an indication that your intuition is correct. Because, as I said earlier, you can have high subjective confidence in intuitions that come from very poor thinking.
And you write that overconfidence is one of the best documented cognitive biases, and that people tend to deny the reality of uncertainty. Can you elaborate on that, please?
Well, there have been really many studies where you ask people to make judgments and then to assign a probability that they're correct. So, was Einstein born, before or after 1870? And people say one or the other. Then you ask them, what is your probability that you're right? By chance alone, it would be 50%. But it turns out that you can look at judgments that people make and say, on this type of judgment, how often are people correct when they make that type of judgment? So when somebody says, I'm 80% sure, in principle, you would want 80% of their judgments when they're 80% sure to be correct. That's what we call calibration in probability judgments. In general, people are not well calibrated. And the direction of miscalibration is overconfidence. So that when people tell you they're 80 or 90% sure, the probability that they're correct is likely to be about 60% and not 80 or 90. That's overconfidence.
Okay. Maybe we take a question from the chat. Yeah, Tullio.
Yes, Piotr is asking, using artificial intelligence in court would probably significantly reduce the noise effect, yet we feel uncomfortable, to say the least, to have AI judges.
In general, I think we're uncomfortable with AI. We're uncomfortable with automatic systems making decisions. Somehow people are strongly biased in favor of human judgment. There's no question about that. The bias is diminishing. And there is really very little question that you could improve on the quality of justice by applying artificial intelligence. In one domain, it's been demonstrated. So the domain is a very simple domain, relatively. It's bail decisions, whether people are required to stay in jail until their trial, or whether they can go free until their trial. It's a very important decision from the point of view of the defendant, because they can wait for a trial for months. Now, on this issue, there has been a large-scale study of 700,000 decisions about parole, comparing the decision that judges actually made to a machine learning solution to the same problem. And it's not even close how much better the machine learning can be. That is, it can keep the number of people who stay in jail the same, and then it can reduce crime by about 50%, or it can keep crime by people who have been released on bail. It can keep that constant and reduce the number of people in jail by 50%. I'm convinced that as we progress, it's not going to happen immediately, but I'm convinced that AI will easily produce judgment that are better than people. I have heard that an experiment on AI justice is being conducted in China, and that the preliminary results are that people are really very satisfied with it. It's in a particular context. It's in the context of bankruptcies. So again, it's a fairly narrow, well-defined problem. But in the context of bankruptcies, again, you can see why and how a systematic way of a machine learning process can reach solutions that are simply much better than human judgment, because human judgment is very long.
Actually, in the book, you write that even simple mechanical models and rules are in general superior to human judgment, even without going to artificial intelligence.
That is true.
And this has been demonstrated, no, from various studies.
Many studies. I mean, there is a long line of studies that compare very simple aggregation of a small number of factors to the judgments of humans that have a lot more information. And the humans are so noisy that the mechanical rules are better than they are. Perhaps the most surprising result is a result that we call bootstrapping. You give a judge a number of cases, and the judge makes judgments, and then you can assess the validity of these judgments. But now you can do something quite interesting. You can develop a formula that will predict what the judge will say. So it's a model of the judge. And now you can take a new sample of observations, and you can compare the accuracy of the judge with the accuracy of the model of the same judge, of the same person. And the model is almost invariably more accurate than the judge. And the reason is the model is noise-free and the judge is noisy. And there's so much noise that it's enough. And even rules of aggregation that are very simple can be superior to human judgment.
And another thing that you say is that replacing absolute judgment with relative ones, so implementing a ranking is likely to reduce noise and works much better. Can you comment?
Yes, I mean, this, give you an example. If you're trying to estimate the length of lines, so you're shown a single line, and you have to estimate it on an absolute scale. How long is that line? How many centimeters? That is actually for most people quite difficult. But if you show two lines and you ask which of them is longer, then that judgment is very easy, especially if the lines are aligned so that you can compare them easily. And this is a general principle, that the comparative judgment is easier than an absolute judgment, where you take a case and you match it to the value on the scale.
Okay. And what characterizes the personality of people with excellent judgment? Are there some particular features that these people have?
We know a lot about that in recent years through a program of research on what is called SuperForecasters. And there is a book with that title, SuperForecasters, by Philip Tetlock and Howard Gardner, I think, which I really recommend. It's a very good book. And they had tournaments where people would make probabilistic judgments about future events. Will there be a war in Ukraine within the next 3 months? That would be the kind of judgment that people would make on many events that could be scored correct or incorrect within a short time. And it turns out that they had thousands of people participating in those tournaments. And it turns out that there is a small group of people, they take the top 2% of the population, and they call them SuperForecasters because they're really good at it. They're so good at it that the judgment of SuperForecasters who have no access to classified information, at least in some cases, has been compared to the judgment of people within the CIA who have a lot of classified information, and the SuperForecasters are better. And now, Philip Tetlock has done a very good study. Philip and his wife, Bob Mellers, have done a very detailed study of what are the characteristics of SuperForecasters. So SuperForecasters are intelligent, that's obvious. They're numerate. And they're willing to change their mind. And that is extremely important. There is a characteristic that is called active open-mindedness, which is that people look for information that is not compatible with what they believe. And the people who are intelligent, numerate, and actively open-minded tend to be much better at forecasting. And I would add to this that they have to be self-critical. It's already implied in what I said, that they should not be too impulsive, because people are very impulsive are not sufficiently self-critical.
And can one be trained and improve judgment capabilities? Is it something one can learn? And if yes, how?
Well, certainly you can train people. So in forecasting, in the last few years, there's been a lot of progress on training people to make the kind of political, strategic, economic forecasts that I've just mentioned. And you can get people to be better. You can score their accuracy basically by the mean squared error formula, and they get better. But SuperForecasters are in part born, not made. That is, you have to have the talent and you have to have the personality to be willing to look for information when you already think you have an answer, to look for information that would disprove your position. That is a personality characteristic, and it's not going to be easily changed.
Yeah. Maybe we take a question from the chat.
Yes. Hugo is asking, Nassim Taleb argues that as you consume more data and the ratio of noise to signal increases, the less you know about what's going on and the more inadvertent trouble you are likely to cause. How to reduce noise in real life, especially applied to financial decisions?
Well, this is important because it helps me clarify what noise is. And the way that we are using noise is variability in judgments. It's not noise in the outside world, but it's noise in people's heads. And I think Nassim has something in mind. And as usual, he puts it in a very extreme way, that quite often getting people more information is more than they can use. And there have been many studies actually documenting that point, that when a person is trying to make a judgment, a complicated judgment, say about the future of somebody or about whether a marriage will be stable or not, and they get increasing amounts of information, they very rapidly get to a point of diminishing return and sometimes negative returns. And that's in part because confidence increases with the amount of information much more rapidly than accuracy does. So when you get more information, you become more confident in the quality of your judgment. But that, because actually the added information doesn't add that much, you become increasingly overconfident, and that sometimes can lead you to make mistakes.
Okay, I would like to discuss performance evaluation. And in a large organization like CERN, performance is evaluated every year, and this process takes a lot of time and really big effort. And these performance reviews cannot be based entirely on objective performance metrics and are largely judgment-based. You write in the book that studies show that the noise component in these performance ratings is huge, and I think 70 to 80%, something like that. And that the relationship between job performance and ratings is likely to be weak or at best uncertain. Where does this noise come from, and how can we reduce it?
Well, the basic finding is really there, that organizations that spend a lot of time making judgments. So there was a study, I think, in, I forget, in one of the largest accounting companies in the world. They did a study of their performance evaluation, on which they spend a lot of time and a lot of money. And it turns out that when you look at a supervisor giving evaluations to several people, and each of these people has evaluations from several supervisors, when you look at a particular judgment, you can learn from that judgment more about the supervisor who wrote it than about the person who is being evaluated. That is, the judges account for more of the variance than the actual people who are evaluated. This is a major problem, and it arises from complicated interactions and feedback loops. So that actually, when you have an employee doing a job and being evaluated, the employee's performance is actually affected by the relationship with the supervisor. So the employee doesn't remain the same person with different supervisors. That is in part the noise. And in addition, supervisors differ from each other considerably, both in how severe they are or lenient, and in the variability that they create. Some people produce very little variability, others produce more, and as a result, there is a very large amount of noise. Now you ask, what can be done about it? I'm not sure I know of any good solution. I mean, trying to be as objective as possible about the achievement of goals and so on, that would probably help. The judgments of peers are more reliable, can be made more reliable than the judgments of superiors, and that is in part because you can obtain more judgments from peers or from the clients with whom an individual interacts. There is a possibility of collecting more information and reducing noise that way. But in general, the prospects for one person evaluating another person on an essentially subjective criterion, that is going to stay noisy.
And can you give your opinion on forced ranking in performance evaluation? That is to say, imposing a certain distribution and say that imposing a certain percentage of good performers and a percentage of bad performance.
I mean, this has been tried. Jack Welch, I think the famous CEO of GE, was a great advisor of this. It clearly, the idea that you fire the bottom 10% of your performers every year is clearly a disaster for morale, and the injustice of it is obvious. When you have a very good team, you really don't want to evaluate to mechanically disregard the differences between the qualities of the team. So a good leader is likely to have a team that in general performs better than a worse leader, and forcing equality is absurd. So this was quite popular 10, 15 years ago, but many organizations use this and given up on the process on forced ranking.
And rating scales are often used for performance evaluation. How can we clarify their meaning and make sure that they are used consistently?
This is really quite difficult because people differ a lot in their use of rating scales. So they, as I mentioned earlier, they differ in their average rating, they differ in the standard deviation, in the variability that they produce. making judgments comparative is one way of doing this. So, for example, when you are, we advocate that if you can, construct a case scale. That is, where instead of having a number that you're comparing an individual to a series of numbers, you are comparing an individual to a series of examples and trying to locate that individual in a scale that is made up of examples that are familiar or that are described in some detail. And so there are ways of reducing noise, primarily through making sure that people use the same frame of reference. That is, that the group that they're using in their head as a reference group is about the same, and making relative judgment with respect to that shared frame of reference is a way to reduce noise.
Okay, but with reference to a large organization like CERN with many different professional profiles, does it make sense to use the same scale for everybody, or should there be several scales? What is your view on that?
Well, there is a limit. Clearly, a single scale is not enough. And it's in particular because evaluations, they don't only have their purpose is not only to decide who will get a bonus or who will get fired. People need the feedback. Employees need feedback, and the feedback has to be fairly detailed. And so rating on more than one scale is clearly valuable, but there is a limit. There shouldn't be, I think 5 or 6 scales is about as many as people can do usefully. And that is certainly useful. And certainly you don't want and don't need to use exactly the same scale for different occupations, because the criteria by which we evaluate people in different positions could be quite different.
And you write the standard and structured interviews are not very informative and often useless. Why?
Well, it turns out the unstructured interview is the normal interview. I mean, you meet somebody, you have a conversation, you try to form an impression, and then you make a judgment. The structured interview is a series of topics or a series of questions that you go through, and you make judgments about each topic in turn. Turns out that structured interviews are much better than unstructured. That doesn't make them good, because you cannot really predict performance on jobs very accurately, and too much happens. It's a long-term criterion. Unstructured interviews, the reason that they're so poor is that people are very quick to form an impression. And I form an impression of somebody, and it turns out that interviewers form an impression in, say, the first 5 minutes, and they spend the rest of the time justifying their impression, getting more information that fits their original impression. This is really a waste of time. So structured interviewing, like structured evaluation, is clearly one way to improve things.
And you also read that recruitment interviews are a minefield of psychological biases. How can we reduce such biases?
I don't think that I heard the first sentence.
You wrote that recruitment interviews are a minefield of psychological bias. How can we reduce such bias?
I mean, the way to reduce the effect of biases is to move to structured interviews. And when you have structured interviews, it's easier to make them objective. So in the sense, not necessarily objective, but factual. So when you talk to people about actual facts about their performance or about their past or about their interaction with other people, you tend to make better judgments when it's factual. And that will likely certainly will reduce noise, and it's also likely to reduce the impact of bias.
Can you be more specific and describe what a structured interview is?
I would say the following, if you want to summarize the value of a structured approach to interviewing, it's an instrument that helps you delay your intuition. The real danger in those interactions or in unstructured interviews is the speed with which we form a general impression. And by breaking up a task of evaluation into several subtasks, several distinct topics, when you do that and you collect a judgment on each topic separately, and you delay the global judgment, the integration, until you have the complete profile of information about the candidate, that is going to work better. And delayed intuition is essential for the reason that I emphasized earlier. It provides more independence between the separate judgments. When you're allowing people just to form an impression and confirm it, you find what we call the halo effect. That is, that actually people are influenced by one judgment they make actually controls other judgments that they make.
Okay, and from what you have said, part of the quality of the quality of judgment would be improved by doing a rating of all these components and do it independently, and then discussing just after, in a second iteration, the result of
And that optimal procedure is really based on independence, so that in the structured interview, your ratings on separate aspects of the features, attributes of the candidate are independent. And if several people are involved, it is really very important that their judgment, that they should get together only at the end, and that they should make recommendations and judgments independently before they start discussing.
Yeah, and there is a question from the chat on structured interview. Would you recommend allowing follow-up questions from the board? Would you rather allow only pre-selected questions, maybe the same for all candidates? What is your opinion on that?
I think that you don't want to turn that into a questionnaire. I don't think that a structured interview should have the feel of somebody reading questions from a list. But the interview will be structured when it has topics. So we are discussing sociability, we are discussing punctuality, reliability, or whatever it is that we're discussing. The topic is clear. There is, in the background of the interviewer's mind, a set of questions, because that can be in part determined by the organization and in part by the interviewer's own experience. But I would keep it conversational, not turn it into a questionnaire.
Yes, and the structure protocol, is it also useful? I guess the same thing applies also if you have to take a strategic decision in an organization, is not only in the context of recruitment, right?
You make me say things that I really would like to talk about. So we discuss in the book, we discuss strategic decisions. And we have a slogan that you will understand now. And it is that options are like candidates. That is, and the idea is we do have an idea of how to evaluate candidates. And we've discussed that in a structured way. And actually you can apply that when you face a decision. Each option can be treated as a candidate, and there are attributes, like the attributes of a candidate, those attributes that are going to be used to evaluate which option is superior to which other option. And the same process of maintaining independence and delaying intuition is applicable to strategic decisions as well as to structured interview.
Okay, it is 5:30, but maybe we take one last question from the chat because there are many.
I should take the first one, I would say. We take TUI. You mentioned group dynamics. In most cases, is the group opinion highly influenced by the noise of the most influential or confident person? How can we deal with noise and collaborative decision making?
In principle, and that's, how you design meetings. Meetings are typically organized in a way that maximizes the interaction between people and therefore reduces independence. To the extent possible, and that is, it would be better to start meetings with people having done their homework, being prepared, and having an opinion, and then you start discussing the opinions, instead of forming an opinion in the course of the meeting. But what I'm suggesting here is demanding. It would take more preparation, and therefore there will be opposition to it. But in principle, there is a way of making meetings much more efficient. And this is by focusing on the preparation and having people make independent judgments. When they make independent judgment, that will reveal the noise. And that by itself is useful, because in a conversation, the effects of one person on the other are such that people may not realize how much noise there actually is, how much potential disagreement there is in the group.
One more.
So we go to Giacomo. Using artificial intelligence in court means using statistical programs and assuming the bias of those who programmed them.
The issue of algorithmic bias is a very big issue. People are very concerned with it. And it's not, those are not so much the biases of the people who construct the algorithm, but the biases are introduced into algorithm by the wrong choice of variables. So, for example, if you're trying to predict, to evaluate the level of crime in an area, and you are evaluating it by the number of arrests, then it's going to be biased if the arrests are biased. So you have to choose your criteria so that your criteria will not be biased. And when the criteria are unbiased, the algorithm by itself will not introduce bias.
Maybe one question by Katerina. When we rank research of our peers, for example, grants or papers, there can be a tendency for the reviewers to be more strict in things they know better, since they can find pitfalls more easily. While this is probably not strictly noise, it introduces interesting overall effects if it's coupled to some of the reviewers wanting to promote research in their own fields over others. Could you please comment on that?
Well, actually it does introduce noise, because when you have different referees who differ in how much they know about the problem, that variability is actually noise, and there is quite a bit of it. And in addition, of course, there are large biases in scientific evaluation and in the evaluation of grants. And this is a major problem for scientific organizations, is how to get rid of it. And very simple.
Okay, Professor Kahneman, here is 5:35. You have been speaking for over an hour. And we have still almost 500 people, so it was a big success. So I think we should stop here, and really thank you a lot for your participation and your suggestions, your advice, and many thanks on behalf of all of us.
It was an interesting. Goodbye.
Okay.
Thanks a lot.
Bye-bye.
Bye-bye.
Bye-bye.